If you believe Britain is one people with one shared ancestry, DNA tells a very different story. Modern borders suggest unity, but beneath those borders lies one of the most fragmented genetic landscapes in all of Europe. In fact, two people born just a few hours apart in Britain can be more genetically different than people living in completely different European countries. England, Wales, Scotland, and Ireland are not simply cultural regions shaped by accents and traditions. They are the product of radically different population histories, preserved in DNA that stretches back thousands of years. To understand why British DNA is so different by region, we have to strip away modern ideas of nationality and return to a time when Britain was not a country at all, but a contested landscape repeatedly reshaped by migration, isolation, invasion, and survival. After the last Ice Age ended around 11,700 years ago, Britain was not yet an island. It was connected to mainland Europe by a vast lowland known as Doggerland. Hunter-gatherers moved freely across this land, following animals and seasonal resources. These early inhabitants of Britain were genetically similar to Mesolithic populations found across Western Europe. Ancient DNA shows they likely had dark skin, dark hair, and strikingly light eyes. But their dominance did not last. Around 6,000 years ago, a wave of Neolithic farmers arrived from Anatolia via mainland Europe, bringing agriculture, permanent settlements, and a completely different genetic profile. Within a relatively short time, these farmers replaced most of the hunter-gatherer population. This was the first major genetic transformation of Britain, and it set a pattern that would repeat again and again, but not everywhere equally. The most dramatic change came during the Bronze Age, when people carrying steppe ancestry moved into Britain from continental Europe. These migrants brought new technologies, new burial practices, and likely Indo-European languages. Ancient DNA reveals that they replaced more than 90% of Britain's Neolithic population within just a few centuries. This was one of the most complete population turnovers ever recorded in prehistoric Europe. But even then, the replacement was uneven. Some regions absorbed these newcomers fully, while others retained stronger continuity with earlier populations. Geography began to matter more than ever. By the time the Romans arrived in the 1st century AD, Britain was already genetically diverse. Roman occupation brought soldiers, administrators, and merchants from across the empire, but surprisingly, their genetic impact was limited. DNA evidence suggests that Roman rule altered culture far more than ancestry. When Rome withdrew in the early 5th century, Britain entered a period that would permanently reshape its genetic map, especially in England. Between roughly 400 and 700 AD, waves of migrants arrived from northern Europe, Angles, Saxons, and Jutes from regions corresponding to modern Germany, Denmark, and the Netherlands. For generations, historians debated whether these Anglo-Saxons were a small elite who ruled over a native population, or a mass migration that replaced it. Ancient DNA has largely settled the debate. In eastern and southern England, genetic replacement was extensive. In some areas, up to 3/4 of the population's ancestry traces back to these migrants. Entire communities vanished genetically. England did not merely absorb the Anglo-Saxons, it was transformed by them. This is why English DNA today clusters closely with North Sea populations. Eastern England, in particular, shows strong genetic links to Denmark and northern Germany. Western England retained more pre-Saxon ancestry, but even there, the genetic shift was substantial. Later events added more layers. Viking settlers left their mark, especially in eastern England. The Norman conquest introduced yet another elite group, though their genetic impact was smaller. Over centuries, England became the most genetically altered region of the British Isles, shaped by repeated migrations that diluted older genetic layers. Cross the border into Wales and the genetic picture changes abruptly. Wales represents one of the strongest cases of genetic continuity in Europe. Despite centuries of conflict, conquest, and political domination, the Welsh population remained remarkably insulated from large-scale migration. The reasons are both geographic and social. Wales is defined by rugged mountains, narrow valleys, and historically poor farmland. These features discouraged mass settlement and limited movement. Invaders passed through England with relative ease, but Wales offered little incentive and strong resistance. Ancient and modern DNA studies show that Welsh populations retain a high proportion of ancestry linked to Iron Age Britons. Anglo-Saxon genetic influence is minimal compared to England, even in border regions. Some Welsh genetic clusters are closer to ancient Celtic populations than to their English neighbors living just miles away. This continuity is not a matter of identity or tradition, it is measurable biology. Wales functioned as a genetic refuge, preserving lineages that were overwritten elsewhere. Scotland presents a more complex picture because Scotland itself is genetically divided. Lowland Scotland shares much in common with northern England. Anglo-Saxon influence reached deep into the lowlands, especially in the southeast. Later Norman settlement also played a role. As a result, lowland Scots often clustered genetically with northern English populations. But the Highlands tell a different story entirely. The Scottish Highlands were among the most isolated regions in Europe for centuries. Harsh terrain, limited infrastructure, and strong clan systems restricted movement and marriage. Communities remained small and insular. Ancient DNA and modern genetic studies show that Highland populations preserve deep continuity with ancient British and Irish populations. Genetic drift amplified local lineages, creating distinct regional signatures that persist to this day. This is why Scottish surnames often correlate strongly with specific genetic markers, and why Highland DNA stands apart not only from England, but from much of Europe.
Ireland, meanwhile, may represent the most genetically continuous population in the British Isles. Despite a long history of invasion, Vikings, Normans, and later English rule, the core Irish genetic structure remained remarkably stable. The key reason is that most invaders ruled rather than replaced. Viking DNA is present, especially in coastal regions and former Norse settlements, but it rarely dominates. Norman influence was largely elite-driven. Even centuries of British control failed to produce large-scale population replacement. Ancient DNA from Ireland reveals strong continuity with Bronze Age populations, particularly in the West. Some Irish genetic lineages rank among the oldest in Europe still present today. This makes Ireland a living archive of ancient Atlantic ancestry, preserved by geography, social structure, and historical circumstance. Viking expansion adds another layer to Britain's genetic patchwork. Their impact was powerful but uneven. In Orkney and Shetland, Viking ancestry can exceed 25 to 30%, reflecting near total replacement of earlier populations. In parts of northern Scotland and eastern England, Viking DNA is significant but mixed. In Wales and much of Ireland, Viking genetic influence is limited. Once again, the same migration produced radically different outcomes depending on local conditions. What makes Britain so genetically different from most of Europe is not diversity alone, but the way that diversity formed. Many European regions experienced gradual blending over long periods. Britain experienced sharp pulses of migration, followed by long isolation. Borders hardened, communities remained distinct. Replacement occurred in some places, preservation in others. The result is a mosaic rather than a gradient. These differences are not relics of the distant past, they are measurable today. Modern DNA testing can reliably distinguish Welsh from English ancestry, Highland from lowland Scottish roots, and even identify regions shaped by Viking settlement. In Britain, geography predicts genetics with extraordinary accuracy. Your ancestry can often be traced more precisely by region than by nationality. This challenges modern assumptions about identity. Britain may be politically unified, but biologically it remains deeply regional. England reflects centuries of migration and replacement. Wales preserves ancient continuity. Scotland contains both transformation and isolation within its borders. Ireland stands as one of Europe's strongest examples of genetic endurance. Each region tells a different story, not in documents or monuments, but in DNA. When people ask why British DNA is so different by region, the answer is not simple. It is the result of ice ages and land bridges, of farmers and herders, of invaders and refuges, of mountains that protected and plains that invited change. Britain was never one people. It was many peoples, shaped by forces that affected each region in radically different ways. And that is why on one small island, you can find some of the oldest surviving genetic lineages in Europe living alongside populations reshaped by repeated migration. One land, many histories, all still alive in the genes of the people who live there today.